First diagonal of Pascal's triangle is a sequence of all ones. And the second diagonal is a sequence consisting of the positive integers in order. The third diagonal is a sequence that can be described by the formula a sub n is equal to n times n plus 1 over 2. And use this information to find a recursive formula for the sequence of terms in the fourth diagonal. So the fourth diagonal is 1, 4, 10, 20, etc. So let me just write this out. So the fourth diagonal, it doesn't matter which way we count. We can do 1, 2, 3, 4, this thing. Or if we count 1, 2, 3, 4, this thing. It's still going to be the same thing because it's symmetric. So I guess the best way to do this is to write it like this. Now, the difference between the first two is 3, then 6, then 10, and then 3, 4, and then 1. So there's 3 differences we have to go to in order for it all to be the same, which means that this is going to be a cubic formula, or cubic polynomial. So if you want, you can work backwards and say, okay, well, this is going to be another one. So we do 4 plus 1 is 5. And then this one, you do 10 plus 5 is 15. And then you do 20 plus 15 will give you 35. And then you can still work your way backwards like this. Okay, so then you know, it's not necessary to do that, but that's one way to do it. The other way, of course, is to draw out the Pascal's triangle. Regardless, what we're going to do is look at a standard form of a cubic polynomial. So that's going to be the form ax cubed plus bx squared plus cx plus d. And we'll say that this is equal to f of x. And so when x is 1, we get 1. So basically, I'll just write an ordered pair. X is 1, y is 1. And then when x is 2, we go down to 4. So when x is 3, we go to 10. Here we have 4 unknowns, so we need 4 equations. So then we go to 1, 2, 3, 4. That's going to be 20. So now we plug it in. So when we plug in x equals 1 and y equals 1, we get a plus b plus c plus d is equal to 1. And when you plug in x equals 2, y equals 4, you end up with 8a plus 4b plus 2c plus d is 4. We plug in x equals 3 and y equals 10, you get 27a plus 9b plus 3c plus d is equal to 10. And then finally we plug in x is 4, y is 20, 64a plus 16b plus 4c plus d is equal to 20. Now in order to solve this, you would have to use row reduced echelon form. And I will skip the steps, but basically you would have to write out a matrix. So the coefficients of the matrix, it's 1, 1, 1, 1, and 1. 8, 4, 2, 1, 4. 27, 9, 3, 1, 10. 64, 16, 4, 1, 20. And so the idea is get all of this down here to be all zeros. And then solve it. So when you do that, you get that a is 1/6, b is 1/2, c is 1/3, and then d is 0. So then we come up over here and we plug it in. 1/6. And because it's going to be a sub n, we should use n instead of x. So 1/6 n cubed plus 1/2 n squared plus 1/3 n. And then d is 0, so we don't need to add that. And then here what you can also do is get a common denominator of 6, and the numerator will be n cubed plus 3n squared plus 2n. But then if you want to factor this further, you can pull out an n, have n squared plus 3n plus 2. and then factor this out into n plus 2 n plus 1 over 6. And so this will be the final answer.